Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. So let's enhance our linear regression model in machine learning. So one of the concepts in machine learning is splitting your data up. So here we have some data on the size of houses based on square feet, and then we have the prices over here. So we're storing this in an array in Python. And what is happening is we want to split the data. So what we'll use is we will use sklearn module over here and the submodule called model selection. And then we're going to import this function. So this is a function. This function exists within this module, and this module is part of sklearn. So when I hover over here, you can see this is a module, and when I do this, you can see this is a module, and when I hover over this one, what you can see is it's a function. So by using this import statement, we are importing in from this library this function. So we're going to use that to split our data set. So this is the data set over here, and we want to split it. So we could manually split this, but why make the manual effort when you can actually use Python libraries and code that somebody else written to do this? So here we're just going to declare some variables. We had x and y, so you can see the data frame over here. X, this becomes the size, sorry, and the y becomes the price. So we got the x and y here. So we will then use these over here, so pass them in here. So you can see we're declaring a few variables. So x training set, x test. For training, we want to split the data up to train the model. And then we'll use the x test to see if our model is working correctly. And same, you need to split the x and y. So this is the x test, x train, x test, y train, y test. And then we will use this function. So you can see this function, because we imported it, it's now available in our code. It's like if we had written this function. And it takes in a few parameters. The first ones are, of course, just x and y variables over here. That's the full data set. And then we want the test size, so 20%. And then this random state basically means every time we run this code, so every time I click play, I come back to it, it will split the same record. So it made, in this case, it will split these records. So how many records have we got here? Yeah, so that's about 80%. And then 20% will be kept separate. So it's going to do that with this random state. So we won't necessarily know. We don't want any bias or, manually cheating the system. So this will automatically do it on a random number basis. And when it does that, when you add this value, every time you run this, because you don't want to keep changing your splits every time you look at your data, by adding this number 42, again, just randomly selected, you can keep the same split. So although there is randomness in it, but you can control, actually, when I relearn this code, I want the same split based on what you selected randomly previously. So if you ask the machine to give me some random numbers, and next day you come back and say, give me the same random numbers you gave me yesterday, that's what this is doing. Then we got the split of the data. So in the next section, we will look at how does this actually get processed. So this is a simple guide on how you split your data for learning, for training your model, and then what would you use it to test your model. Of course, you want to keep like some questions and answers separately, so you don't want the model to train on your test data and so on. So that's why we do the split. Let us talk through this train test split. So this is a function, as you know, we imported in from this library. Notice again the from statement. So we are bringing in from this module. You can see it's the module, and we're bringing in the function, and this is used to split data. Now we could manually split the data between what we train our machine learning algorithm on versus what we test it on. So why do we do that? Why do we actually do the splitting? So these are the sizes of the houses, and this is the price. So if we have a look at the output to understand what is going on. So when I output here the training set and the testing set, so you can see the data is split. So this is the original data over here. And what I want you to notice is the row numbers on the side. So that's row number 0, row number 1, 2, 3. So these are the unique IDs data frame gives automatically. Now in the training set, what I want you to notice is as to why we use this function. It's a built-in function into this library here. So we didn't write any of it, and we gave it that we want to select 20% of the data for testing, and we want it to be random. And notice here this unique number 42. This is just something I've selected, which will ensure every time I click play, it will generate the same set of sequence. So if we have a look at the training set here, you can see index 5 there is the data point that's been selected. So that that's there. So notice here the number 5 that I've moved here. This is all as part of this function. So this function's job is to move the data about and randomly select. So its randomness is still controlled by this variable here, but remember, this is just a random number we've selected. So what we want to do is every time we run this, we don't want to keep chaining the row order and so on. So there is a randomness, or it's a controlled randomness. So still it doesn't have any bias. So if we have a look at the training set data over here, so you can see all the rows, row 0. But if we have a look at the test data, which is this one over here and this one, and we look at the value. So it's row 8 and 1 that have been selected from the original. So 8, that's that one, 2500, and row number 1, 800, that's this one over here. So the reason we do the splitting like this is for training, this is for testing, and we can see the output of that. The reason we do run this function is the training set is used to train the model, allowing it to learn patterns. So we want it to learn from the data patterns we have here. And why do we select few rows like the row number, this one, and I think it was this one that we selected for testing? Why is it this is kept separate? This is kept separate because it's used to assess a model's performance. So we can test how accurate, if we kept this data hidden from it and then later on use the model to check accuracy, then the model wasn't aware of this data. It allows us to check accuracy basically of our model and its performance. So just to reiterate, why in machine learning we split the data between a training dataset and a testing dataset. So as you know, what we can do is here our dataset over here, and for some of it, what we want to do is we want to maybe take 20% of the data for testing, and rather than manually splitting the data, because previously what you can do is you can use function over here, which is train test split. What this function does is it lets you put in your data. So these are the x's, and then this is the y values. So here, so you can see we said x is size, y is the price, and you can see here we are saying test size is we want 20%, and here this is just a random number. This is to randomly select some values, but every time we run this cell, then we want the same selection of values to be selected. So this 42 ensures that we do that. So, but the question becomes is why do we split between training set and testing set? Why do we do this? So I want you to imagine yourself where you in your own kitchen at home practice making cakes. If you make cakes and you taste your cakes yourself, you're a brilliant baker and you are able to make the best cakes. But the actual result is you going to your friends or out there in the public, giving people tasters of your cake and saying, what do you think about my cakes? I know I'm very good, but what do you think? So those extra people, those people that might be in your own kitchen, for example, your own family, they might go, you're a brilliant baker. But what you want to do is you want to save a few people separately. So maybe, out of this data, keep 2 people separately and then ask them, what do you think of my baking skills? And this is exactly why we split the data. We let the model, the machine algorithms learn from this data, but in order to be 100% sure that the model is working, you keep some of the known data separately and you test based on that data, and the output that you get will determine how good your model is. So the basic purpose of testing essentially is the testing data is used to evaluate how accurate and how good your model is. Because if you use the testing data again, so let's say you used all of this data here in your testing, of course, it's going to be pretty good and you're going to get very good results because if already seen this data, if you show some students the answers to the exam and then use at the other end, you go, actually, they go 100%. The reason they go 100% mark is because they've already seen the answers. That's why you keep some of the data that you know is accurate. You keep it separate so that you can test your machine learning algorithm. So basically, you're hiding it from the computer algorithm. They doesn't know about it. And that's what training set and testing set does. So again, now that we have split our data between training and testing, so by that, what we mean is we are just splitting the data over here where we take 20%. So this is 20% of the data we have. We take it as testing data. And previously I've explained you can use this function that's built into this module that you're importing. So it's part of the sklearn model selection. And within that, there is the train test split function. So we didn't write this. This is pre-written. And all we do is we give it some arguments over here and it goes away and outputs the results into these variables. So x train. So what we're doing is for the x variable, that's what we will use for training, and x test. So again, some some of the data, 20% would be selected to go into testing for the X variable. And this is what the X variable is. So this is the size, and Y variable is the price. So this is the house prices based on the size. And the same thing happens. So Y train in Y test. All this is doing is it's going to select some of the data for training. So it might go, because we said 20%, so it will select these at random to be part of the training, and then it might randomly select these two for testing. Again, this is just pure randomness. I'm just selecting to show you what it would mean. And once we've done that, again, the random bit actually is defined here. So again, watch my previous explanation on this. But let's just continue. So we've split the data up. So now, as you can see here, all I'm doing is using pandas. I am just concatenating two of these variables. Remember, it's split them out. So all I'm doing is just concatenating them purely for show and tell purposes. So this isn't needed as part of machine learning. This is just to show you on screen with the print statement what the test data that's been selected. Again, over here, we've just said X test, which is over here. That's the variable there. And you've got the Y test, which is defined here. And we're just saying based on the axes here. So this is the ID numbers from the original dataset. We can see that the following values have been selected for testing. So because we said 20%, that basically means two values selected. So the house side with 2,500 and a price of 600, and a house side of 800 and a price of 250. So these have been separated out and not used for training the algorithm. So these will be used for testing your model after it has been created. So next we will look at that and see how the model is created and how do we actually test it based on the data we have here that's been selected. So remember, most of the stuff is pre-written and you're just using it with your own data, and that's what makes it very nice to work with in Python using the various different libraries that are already written for you. So you don't need to be an expert to use. So just continuing on from our test data selection here. So we selected these two records are the records that we are going to test. So this is about 20% of the data. Remember, the data set we are using with this machine learning algorithm linear regression, we only have a small data set. As you can see here, we don't have many records at all. So we only have a small data set here. And what we want to do is, out of that, we just selected 20% for testing. So the next step is, once you've selected 20%, you want your model for whatever the data that you're using for training, you want to build a model on it because you want to work out for any random data that you give it, what would the house price be? So we know based on the house size here, these are the house prices. But what if you gave it some random size and random price? So rather than make up those random values, because you won't be able to judge the accuracy of your model because you don't know what the actual prices are. So what you do is you just save yourself two records, 20% of this data. Remember, if it was thousands of records, 20% would be a large value. So I'm only showing it for demonstration purposes, but this logic would apply to massive data sets. So you can select 20% of your data. In this case, it would probably be two records, and those two records are randomly selected, not with no bias or any, manual selection process, because remember, we're using the automated built-in functions within sklearn to select our test data and training data. So you build your model over here, and this is the function. So remember, here this is a class, and we're just creating an instance of it. Remember, I talked about classes. So this function here, it's part of linear regression here. This is a class, and what we are doing here is we're just creating a copy of it. And then we call this function model.fit. We pass it to the two variables, our training data set. So this is the X values and this is the Y values. Remember, X is the size, Y is the price. And you might be wondering, where did I get the train underscore train? Because it says here X, there's no train. It's because we use this function to split our data between training. So 80% of the values selected here are for training and 20% are for testing. Remember, I'm just highlighting these for demo purposes. These have been selected randomly, and we printed what values have been selected for testing, and you can see the size here was selected and here was selected. So the rest of the data we are actually going to be using for our training here. So 80% of the data for training, and once that training is done, what we are going to do is we are randomly going to predict based on a house price and see what value we get, and then later on we're going to check how accurate our model is based on the test data, because you need to know the actual values. The linear regression model based on the size of the house and the price of the house. And what we've done so far is randomly selected some data to be used for training, and randomly selected some data that we have here for testing. And the reason for this is to check a model's accuracy. Why do we not make up random data for testing? That is an important concept. So why is it that we have to select from our existing data to evaluate our model's performance? The reason for this is you want to know out of your existing data, which of these values provide a good indication how well your model is. So you wouldn't just randomly throw some data at it and go, "Ooh, actually, my model is brilliant," or it's actually terrible, because you want to use the existing data that you have, because you do not want any bias as well. By randomly making up numbers, you're not actually able to judge how accurate it is. But if you already have the answers, so what essentially, think of it like this. You have the questions and answers. So these are the questions and these are the answers. But if you keep 2 questions and 2 answers of those questions separately, then you can give that to the model that's learned based on all this other data. So all this other data up to here, you can then give it some data that it had not seen and ask it, well, this is the question I'm asking. Can you give me the answer? And if it gives you the correct answer, you go, my model is brilliant. It's really a good student and it's done a good job at it. But if you give it some random questions that are not related to your data, then you won't necessarily have the answers to them. So that's why you keep some data for evaluating your model's performance. So when you come down here and use this function to do the splitting, what you do next is you ask it to predict a value and it will give you the value. So we're going to have a look at that. So we built the model here, we trained it here. What we are going to do is train based on the value supplied here. But if we go over here, so this is the size of the house, 1000, and we want to see its price. So it's predicted to 90. Now, in our data set, let's have a look at the house that is 1000 square feet is actually worth 300,000. And the prediction that it came out was 290. So it's off by 10,000. But is that accurate enough? Do you think that this is reasonable? Is your model quite good? Next, we'll look at that in more detail. So previously, we looked at that our model predicts the house price of 290. But is that accurate? Well, we looked at the actual data. So when we supplied a house size of 1000, it predicted 290, but the actual price is 300. So is that good enough? A difference of 10,000. And this is where we look at how do you judge the accuracy of your model. So in terms of judging the accuracy of the model, you have to split your data between training and testing. So for training, we used some random values from here and for the data for the prices as well. And then we selected some for testing and we selected 20%. So now, in order to judge the performance of accuracy of the model, so we put in, for example, if you look at this, we asked the model, so model.predict, and we passed it a size of 1000, okay? And it predicted, so then in the next line, this is the predicted price, we just basically printed that price. So when you look at this bit, the predicted price, you need to judge, is this correct? So one of the things that you need to look at is the feature importance. So the feature importance here is what would the price change by for every time the size of the house increases by whatever unit that you've specified. So in this case, the unit that we specified is in square feet. So for example, this is 650, 800 square feet, this is 1000. So every time it goes up by, the house price would go up by this amount, so 0.211. And then you can see the intercept value. This is what the base price would be. So the intercept is the base price, the starting price of any house. So a house with 0, for example, size or 1, this is the minimum price. So this is like the standard. This is where you would start off the bidding, the minimum bidding price, what you might say, for example, like on an eBay auction. So that's the minimum amount it would take. And then you have something called the R2 value. So this is the value that actually shows you how accurate your model is. So in this case, if it's closer to 1, so this is 0.9, and if you were to round this up, this would take you to 1%, 1.0, 100% accuracy. But remember, no model should be 100% accurate, because otherwise it's too accurate, too good to be true, in effect, because it's overfitting your data and it's following your data, which isn't good. So here you can see that actually our model, by just this value alone, is pretty accurate. And next we'll look at some of the other options, which is the mean absolute error and root mean squared, to just dig that into a bit more detail. And we'll also look at this chart and explain how it works. So remember, the house price that we got here, which is predicted based on 1000, is 290. We know the actual price of that is actually 300, but we got 290 290. But we can see based on the model output that we got with the R2 value, our model is pretty accurate. So let's take a look at this 0.9991 R2 accuracy value and think about why it is so accurate. So our model seems like it's amazing. So why has that happened? And this is important that you understand how the R2 value is actually worked out and what do they actually show you. The important thing to first be aware of is we have said that this is based on test set. So this is important. Test set. So what does that actually mean? Model accuracy based on test set. So not just on any data set, on test set. This is because when we started to build our model, we said this is our full data set. So these are the house sizes and these are the prices. Then we split them into X and Y. And then we said we would split our data using this built-in function into this module. We will use that to split our data up to 20%. 20% of the data will be used for testing. And we said that these are the two values. So house size, the price of 2,500 square feet versus 800 square feet and the house prices that we have. So this is the test data. So out of this one, so as you can see, 2,500 exists within the data set and that has been selected for testing. And the other one that's been used is 800. So 800 exists within our data over here. And you can see that that's a house price stat. So the important part is when we look at this R2, it's based on test set. So it's just basically based on those two records. So let's demonstrate this on the graph. So those 2 points. So here you can see the test data is in green. So we know there was a value around 800 square feet. So that's that one. So this is the size over here. So we're going size and we're going price over here. And you can see the other value that we had was 2,500 and that's where it is. So the model has basically predicted this line of best fit. Okay. So, and the blue ones are the training data. And why did we get, so the question becomes, why did we get 0.9991 accuracy? That's 39 accuracy. Why is it so accurate? So if you look at the graph, you can see one of the points is actually pretty bang on. It's right on the line. The other one is slightly off over there. So based on that, it works out this R2 value. And you can see some of the data points, more the one we use for training, some are off. So in some instances, the value here is, if you were to predict it on this value, so which is, if you go that from here, you can see that it would predict a price of around this value, which would be maybe 320, but the actual one is a bit higher. But on some situations, it's actually pretty good. It's right on the line, but you can see there are some which are under, there are some which are points which are over that line. And you can see with the R2 values in the green that these are actually, one of them is on the line and one of them is just under the line. So that's why you get this accuracy figure here. Remember, this is a very small data set. If you were to amplify this over a large data set, you would get similar outputs. So of course, it would be much harder to show you it in the example. So that's why we have a small data set to demonstrate all this. So let's continue to look at these aspects more in detail in the next explanation. So as discussed previously, we were looking at our test data over here. And based on the test data, we predicted that our model is actually pretty accurate. This is because, as you can see here, the red line is what the model is. Basically, that's the formula that it has predicted. And this is the predicted line. And you can see the green points over here and over here are our two test data points for our house prices. So one important thing to note with our two model accuracy figure here is it's purely based on the test data. So if you look at we only selected 20%, our data set is quite small. So we only selected 20%, which means it only selected two values over here. So you can see the size and the price, and we have two values, 2,500 size and 800. And what we did was over here, we imported in this function from sklearn metrics R2 score. So we didn't write this. And what this allows you to do is pass it your Y test values and Y test predicted values. So test predicted values are gotten from here. So you pass it your test X values. If we go over here and you can see that's the X axis because we said X is actually the size of the house, Y is the price. So on the graph, as you can see, X is the size over here and Y is the price. And if you say a house which is 2,000 square feet, then as you go up on the line, you can say, okay, based on going up the line and where I touch that line, if I go across and read the value from there, so it's about $500,000. So going back here, that's why we give it some X values, which are their test values. So we give it the X here, 2,500 and 800, and we ask it to predict these two values. So we know the actual values, but we want the model to predict. So what the model will do is it will go, okay, 2,500, and it will go over there here, and what it will do is it will predict the price over here. So you can see the actual point is there, but the model will actually predict it to be somewhere there. So it's slightly higher price prediction versus the actual value, which is slightly lower. But in the other test data value, it's actually pretty bang on. So the actual and the predicted values are pretty close. So if we go over here and look at that, so what we're doing is to get the score, we use this function R2 score, which is imported in from here. And you can learn about import statements in my other explanations. And you can see here Y test and Y test predicted. So Y test predicted is here. So the model will give you the predicted values, and we already know the Y values based on the test data we have. So these are the actual values. So what it's doing is comparing those two values and saying how accurate your model is. And that's what the R2 value is, how accurate that figure is. So that's why we got this 0.9991.